Hello everyone. So today we are going to solve this LeetCode problem, which is longest balanced substring 1. What this question says that we have been given a string as consisting of lowercase English letters. And what we have to do, we have to find a substring that is balanced. And what is a balanced substring is all the distant characters in substring appears the same number of times, which means the frequency of all the distant letters in our substring should be same. Okay, for example, here we have two distinct characters, that is a and b, and the frequency of these two are 2, which is same. Okay, so this is a balanced substring. Okay, we could have c here. So in whole string a b b c, this was our balanced substring, and we would return the length of the longest balanced substring, which would have been 4. Okay, see, this would have been also a balanced substring, this b and c. But why we are not considering it? Because its length is 2. And what we have to return? We have to return the longest balanced substring. Okay. So similarly, this example also is same. Here a, b, b, a, c. This string is our longest. See, this is our longest substring, which is having the same frequency of the distant letters. So what we can do, we can find the frequency of all the letters in our string. Suppose it is A, A, B, C, C, B. Okay. So here what would be C? It could be this one. See here distant letters are 1 and frequency is 2. Okay. Here in this what we have, distant letters are 3 and frequency is 1. Okay. Frequency is as 1 or 2, frequency should be same. We don't have to find the maximum frequency. Okay. We just want to find the longest substring which has number of distant character letters, and the frequency of all those are same. So this has 2, this has 3 length. Okay. And similarly, see this substring, what is its length? Its length is 4. And here distinct letters are 2, that is B and C, and the frequency is 2. And if we take this one, this entire substring, so here distinct letters are 3 and frequency of each letter is 2, which is also same. So this will be our longest substring. Okay. So what we can do, we can find the we can iterate through each substring, and what we can do, we can find the number of unique letters which are distinct letters, and check if the frequency of all those distinct letters is same. If it is same, we will update our answer and we'll get the longest substring in our answer. Got it? So let's see how we'll code this. Okay. So what is given is a function longest balanced, which is having a string s. So what can we do? We can first find the size of this string, which is s dot size. Then what we can define a vector of integer type, which will be having length as our string, and What we'll store in this vector, we'll store all the letters in the integer form. Okay, where a is treated at 0 and z is treated as 25. Okay, so simply we'll do minus a. So from the ASCII code, we'll get all the values in our vector. Now we'll store our answer in our variable. We'll define it initially as 0. Okay. Now we'll iterate through the string. L is equals to 0, L less than N, L plus plus. Okay. And what condition we'll check? If at any condition N minus 1 is less than equal to result, in that case we'll break. Okay, this will give us an early exit. Okay, now what we'll define a integer counter array which is initialized initially as 0. This will have a count of every character. Okay, then we can define variable to track the unique characters and the maximum frequency. Okay, now what we'll do, we'll take another loop in which we'll iterate through all the substrings which we'll get, which are starting from our L going till and R plus plus. Okay, here what we'll check, R in of I is equals to A of R, which is with the vector which we had defined. Okay, now what we'll check, if our count of I is equal to 0, that means it is unique character, then what we'll define, we'll increment the unique character, and simply we at each iteration our counter should be increased only. Okay, now if is max frequency, then our max frequency would be equal to count of I. Okay, and now what we have to check, that if all the distant characters have the same frequency, then this is plus 1. How we'll check? If the unique frequency, which is max frequency, is equal to current, and current is greater than result. Because if it is not result, then we already have a substring which is longer. If it is not, then we'll update our result with the current frequency. Okay, and simply at last what we'll do, we'll return our result. This is a brute force approach and it will take O of n square time, and this was a medium level problem. It could be easily solved using brute force. So if you have any doubt, just put it in the comment section, or any suggestion,